So here are the two problems that I promised to do. First of all, I need to remind you that we learned today about two equations. We learned that wavelength is equal to the speed of light divided by the frequency. So we would write that as wavelength, lambda, is equal to the speed of light divided by the frequency. From now on, I'm going to start writing this equation as c is equal to lambda nu. So once again, this is speed of light. This is wavelength. And this is frequency. That's a Q. And this is the Greek letter lambda. And this is the Greek letter nu, Nu. Okay, so we want to know the frequency of the light with a wavelength of 410 nanometers. Since the speed of light is typically given in meters per second, we're going to use 3.00 times 10 to the 8th meters per second. We need to change nanometers to meters, so 410 nanometers times, unit on the bottom, nanometers, unit on the top, meters, 1 meter, 1 times 10 to the 9th. We've been working with that quite a bit, so that should be an easy question for you, or easy thing for you to do. So it's 4.10, actually it's just 4.1, because there's no significant figure. This 0 here is not significant because there's no decimal. So 4.1 times 10 to the -7th. All right, that's our speed, that's our wavelength. So now we're going to use this formula. C is equal to wavelength times frequency. We know the wavelength is 4.1 times 10 to the -7th meters, so -7th. We know that we don't know the frequency, so we put a nu in there. The C is 3.00 times 10 to the 8th meters per second. So to solve for the frequency, we just divide both sides by 4.1 times 10 to the -7th meters. When you do that, you get 7.3 times 10 to the 14th equals the frequency. Let's talk about units for a minute. We've got meters per seconds divided by meters over 1. So when you divide fractions, you actually multiply by the reciprocal. So that turns into meters per second from here times 1 over meters. So meters cancel. That leaves us with 1 over seconds. Okay. Now you may remember that wavelength is measured in meters, but frequency is either measured in cycles per second. Oops. So what I'm trying to do is get around that M. Cycles per second. Or 1 over seconds, or hertz. So a cycle per second is usually abbreviated 1 over second, so that implies 1 cycle. All right, so you see our unit here is 1 over second, but 1 over second is the same thing as a hertz. So our final answer will be in hertz. All right. Second question, what's energy? Remember, there are two equations we learned today. This was the first equation. The second equation was energy is equal to h nu, where E stands for energy measured in joules, h is Planck's constant, and that is frequency. Okay, and the numerical value for Planck's constant was kind of a weird value. You might remember on the board it was 6.63 times 10 to the -34th joules per hertz. Okay, so energy is equal to h times frequency. We know frequency and we know h, so it's pretty simple. 6.63 times 10 to the -34th joules per hertz multiplied by the number of hertz, which is 4.31 times 10 to the 14th. Notice that hertz cancel, and I just end up with a straight up joules, which is 2.86 times 10 to the negative 19th. And there's your answer for that one. I'm going to go ahead and do number 4 because it really ties together both equations. So we're looking for energy. So energy is equal to H times nu. I'm going to re-erase that and try and make that a little neater. There you go. Okay, we know Planck's constant is 6.63 times 10 to the negative 34th joules per hertz. But we don't know what the frequency is because we're given the wavelength. So we use this equation. C is equal to wavelength times frequency that we used earlier. 3.00 times 10 to the 8th meters per second is equal to 6.62 times 10 to the negative 7th meters times nu. Now you notice I got this number by doing this math in my head. So I had 662 nanometers. Nanometers bottom, meters top, 1 times 10 to the 9th. So I divided that out and I got that number. Okay, so if you do that, then the frequency is, on the calculator, comes out to be 4.53 times 10 to the 14th. And once again, you're dividing both sides by 6.62 times 10 to the negative 7th. So you end up with meters per second over meters, which works out to be 1 over seconds, like I showed you earlier. And another name for a 1 over second is a hertz. It's a 14. All right, so you're going to multiply this number by 4.53 times 10 to the 14th hertz. Notice hertz cancel, and you end up with joules. The answer is 3.00 times 10 to the negative 19th joules. Now, one other thing I was going to say about this, if I wanted to, I could have rearranged this equation over here. I could say if C is equal to wavelength times frequency, then frequency is equal to C divided by wavelength. I could divide both sides by wavelength. And if I did that, then I could say E is equal to H times C divided by wavelength. That would then have given me a one-step option to solve this problem. You just plug in H, plug in C, plug in wavelength, and solve for E. Okay, one other last comment. Eventually we'll do this whole sheet, so if you want to get a head start, you're going to have to add these two energies together. So the energy in this question is 4.8 times 10 to the negative 19th. And it'd be 4.80 because that's to the hundredths place and that's to the hundredths place. Check and see if I did my sig figs right up here. Up here I had 3 sig figs and 3 sig figs, so we're good. And on number 2, 3 sig figs, so we're good. And up here we only had 2 sig figs here, so my answer needed to have 2. All right, hope that helped. And that's a review of the last things we did today.